We're going to be talking about electromagnetic waves here. Particularly, we're going to consider a woman located 170 meters from a radio transmitter. Part A asks how many wavelengths is the woman from the transmitter if the station calls ESPN at 1160 AM. Okay, and if we know or don't, the question tells us that it's in kilohertz. Okay, so what are we going to do here? Well, immediately we'll go ahead and write down our equation. C equals lambda times f, where lambda is our wavelength and f is our frequency and c is the speed of light, which is going to be constant in our air. We can go ahead, and if we want to calculate the number of wavelengths between the women, we'll go ahead and take the distance that she is, so d equal to 170 meters. And we're going to divide that d by the number of wavelengths between them, between her and the transmitter. Okay, but let's figure out what our wavelengths are. So we go ahead and solve for wavelengths by dividing out the f. So we have wavelengths is equal to c over f. And let's just kind of number of wavelengths. And if we go ahead and plug that in, so over f, not lambda, right? And if we go ahead and plug that in here, we have the number of wavelengths is going to be equal to d over c times f. Okay, and now we just plug in what we know. So we'll have number of wavelengths is equal to our distance, 170 meters, times the frequency, which is going to be 1160 times 10 to the third, because our SI units is in hertz. All divided by the constant c, which is going to be simplified as 3 times 10 to the 8 meters per second. Okay? And if we plug this in and type it into our calculator, we'll see that our number of wavelengths will be 0.66, meaning we have approximately 2/3 of a wavelength between our woman and our tower. Let's go ahead and sample that. All right, so for part B, what we're going to do is essentially the same thing. We want to find the number of wavelengths between the woman and the transmitter. But if the station is giving off 89.9 Jazz FM, all right? Instead of AM, we have FM. That is the main difference between these two parts. And in FM, we're going to have megahertz as opposed to kilohertz. Okay, so if we go back to our original equation, we'll have number of wavelengths, which we found by inputting our equation for lambda into d over lambda, which is our number of wavelengths. We will again have d over c times f. Okay, our d and our c will stay the same, so we'll have 170 meters over 3 times 10 to the 8 meters per second. But now we'll have 89.9 megahertz. Okay, so if you guys remember or look at your formula sheet, that will be times 10 to the 6th hertz. If we go ahead and calculate this out, we will find that there will be 50.94 wavelengths in between our friend and the transmitter.